you will learn to how to count things. Like you do the counting when you're in elementary school or something. And how we do counting in math? We're thinking about like what would we say that 3 apple has the same number as 3 bananas, something like that. Well, how you do that is you do some correspondation between apples and bananas. So you do like, okay, this apple corresponds to that banana, this apple is that banana, this apple is that banana. So you have same amount of apples and bananas, something like this. I think in high school they told it by 一对人民, something like that, in combinatorics. And we use this kind of notion when we're counting infinite number. Like, so we're saying that if we can do some pairing between 2 different sets, then we say they have same amount of the numbers of the elements. So you can think something like this way. 1, 2, 3, 4, 5, blah, 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 blah. 0, 1, negative 1, 2, negative 2, blah, 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 blah. So actually, you constructed a correspondence between the natural number and the integers. So we are saying that they have the same amount of elements. We call it countable. And actually, there are sets like they have too much elements, so that you cannot find such a function to n, and we call it uncountable. Now you will see in the next week video. And I think the last part, countable. Okay, you will learn another thing. It's called metric space. Metric space. Metric means distance. So, like analysis want to control the errors, right? Not only error between numbers, but like error between functions, between sets, between a lot of things. So we want to calculate some kind of error. We're actually extend the notion of distance, or we're thinking about there is this distance to measure the error of function or the error of sets. So we're not only thinking about distance as the Euclidean distance we use on the Rn, but we like seeing a distance in a more abstract way. We extend the notion to the metric, and we'll define if the space has a metric, which means that you can define the distance on it. We'll call it metric space. So there must be a question like how to define a metric space in your next week quiz, right? Try to make sure you figure this one out, or you memorize it. You can copy it on your quiz sheet. I think that's the end of today's class. There's no problem there.